Hello everyone. Today, we're going to talk about something small, but very important in electronics, capacitors. Have you ever wondered what capacitors actually do in a DC circuit? We often hear about them in electronic devices, but how do they really work? Let's find out how this tiny component plays a big role in keeping our circuits smooth and stable. First, let's start with the basics. What exactly is a capacitor? A capacitor is an electronic component that stores electrical energy in an electric field. Think of it like a tiny rechargeable battery. It can store energy and release it when needed. Unlike a normal battery though, it charges and discharges very quickly. Now that we know what a capacitor is, let's see how it works in a DC circuit. When a capacitor is connected to a DC source, it begins to charge. The voltage across it increases gradually until it matches the supply voltage. After that, current stops flowing. The capacitor is now fully charged. In circuits such as rectifiers, this stored charge helps to smooth out the DC voltage, removing fluctuations. So, why do we use capacitors in DC circuits? They serve three main purposes. First, they smooth voltage, keeping the current steady. Second, they filter noise, reducing unwanted signals. And third, they store energy, ready to release, when the circuit needs it. These simple functions make capacitors essential in almost every electronic device. Let's look at a real example. In a rectifier circuit, a capacitor is used to smooth out the DC voltage that comes from converting AC power. Without the capacitor, the output voltage would ripple up and down. The capacitor fills in the gaps, storing charge when voltage rises, and releasing it when it drops. This makes the voltage much more stable, just like in your phone charger or computer power supply. So, to sum up, why do capacitors matter? They store energy, smooth voltage, and filter noise. These small components keep our circuits running efficiently and reliably. Without them, electronics would be unstable and noisy. Small components, big impact. Thank you for watching and learning with me. See you next time.